In this final section of Chapter 4, we are going to talk a little bit more about our linear model. We are going to talk about evaluating it, and we're going to talk about kind of some different mistakes that we want to avoid, as well as one more thing called our coefficient of determination. So in the last section, we discussed regression lines, linear models that explore the relationship between linearly associated data sets. We use the model to predict expected values, and we can gain useful information by interpreting the slope and oftentimes the y-intercept as well. In this section, we're going to discuss potential interpretation pitfalls to avoid and how we can determine how well the regression model fits the data. All right, so interpretation mistakes to avoid. The first mistake that we want to avoid, do not fit a linear model to a nonlinear association. Right? So if we have something that looks like it is showing a curved or changing data association, we want to make sure that we are not trying to force a linear model onto that. The straight line regression is a poor fit to this linear relationship, nonlinear relationship, because as we look at this, we have kind of more of a curved shape here than we do a straight line. Right. Our second thing, which we've already talked about, correlation is not causation. Right? An association between two variables is not sufficient evidence to conclude that a cause and effect relationship exists, no matter how strong the correlation or how well the regression line fits the data set. Right? Again, be extra cautious if you see the word causes in any of your homework problems. Use caution when analyzing aggregate data. Right? Aggregate data are those for which each plotted point is from a summary of a group of individuals, such as a mean. There may be a correlation between the groups, but we cannot necessarily say that there is a correlation between individuals. So if you're given some sort of information like that, we just want to be careful about our choice of wording and that we're thinking about groups rather than individuals. All right, the next one on our list, beware of outliers. Right, we talked a lot about outliers in the last chapter as well. An outlier can have a strong influence on the regression line because our regression line is based on our mean and our standard deviation. Sometimes we also refer to outliers as influential points because of this influence that they have. So when you have influential points, it is a good idea to look at the data both with and without the points. So in this little picture here, we see the same data set. This one we have one value that's way over here. We have a much different line than when we compare it to that. So it is a good idea to look at the data both ways, see which one is the best fit for our model. Right. And then the last thing we want to avoid, don't extrapolate. Extrapolation means we use a regression line to make predictions beyond the range of our data. We cannot extrapolate because we cannot be sure that that linear trend will continue beyond the range of data. So these are all different things that we want to avoid when in our interpretation, mistakes that we want to avoid. Again, some of them we've already talked a little bit about. The last one, the extrapolation, we will take a closer look at in the next video.